Okay then, without further delay, let's get started. On behalf of Amphenol Canada, I'd like to welcome you to our presentation on filtered connectors, which should run about 30 minutes or so today. This is the first in a series of educational webinars that we'll be organizing in the near future. I'd like to note again that all of the attendees have been set to mute in order to minimize background noise because we will be recording this, but I do encourage you to make any comments you may have throughout the presentation in the chat pane. At the end of the presentation, we'll do a Q&A for any questions you may have, and at that time we'll address any questions from the chat pane that have not already been answered during the course of the presentation. Our presenter today is Franco Minatel, who is an experienced engineer in both the mil-aero and the automotive industry. He has been a design engineer at Amphenol Canada, designing filtered connectors on 2 tours of duty before shifting into the marketing application engineer role. So Franco, I'm going to shift this over to you.
Okay, hello everyone, and thanks for joining us. We're going to be discussing filtered connectors, and we're going to just give a basic primer on the different types of filtered connectors that you can use and what type of applications you can use them in. When should you consider a filtered connector? Well, there's really 2 times. Obviously, in the design process, when you're laying out your system and your EMI requirements, that's a perfect time. So you get it designed in right up front and you're ready to go. However, if you've already designed something, an assembly, your system, and it's already working, but you've noticed you've got EMI issues, an EMI filtered connector can be used in retrofitting your system. And that way you can have all the EMI benefits and all the filtering capabilities provided to you after you've designed your assembly. Okay, so first of all, what is a filtered connector? A combination of filters in a single compact interconnect device. What we do is we provide you with a capacitor and an inductor, possibly if you require that, to filter out EMI noise. It provides attenuation to filter out the noise, and it keeps the noise and transients outside of your box and your system. So again, like I said, this is perfect for a retrofit solution where you can substitute your non-filtered standard connector with a Amphenol design filtered connector. So the benefits of a filtered connector. So you get better EMI control. Now let me tell you a story about EMI. A colleague of ours was actually in the Air Force, and I forget which plane he was on, but he noticed that while he was communicating on the radio, and luckily the plane was on the ground when this was happening, as he was communicating on the radio, transmitting frequencies, he noticed that the flaps were moving up and down. So that's a clear case of EMI, electromagnetic interference. It was messing up the signal of the flap actuation, and and it was coming from his radio. So this is where you would like your system to have some type of control. Now, what a filter connector can give you is space reduction within your LRU, or line replaceable unit, and by having by removing PCBs and extra bracketry required to mount your printed circuit board. It can give you cost savings by eliminating the need for the design, by reducing the amount of components in your system, as well as the robustness of the system, because everything would be contained within the connector. You don't have those boards or other units within the box. It's easy to upgrade your system by installing a connector. Now, we're going to look at weighing out the differences between the two EMI type of solutions. So you have your discrete filter system where you design the components, circuit boards to filter out the noise, or you have a filter connector. So the thing is, with the discrete filter system, you'll have extra room in the enclosure that you need to accommodate for the printed circuit board. You need some proper grounding, springs, or coils to kind of ground out the board and your system. One thing that you don't get with a filtered connector that you do get with a discrete filter system is that when the signal enters your LRU, it can be contaminated with EMI, or let's call it a dirty signal. So you have a dirty signal entering the box. Then what can happen is, as you're taking that signal from the lines using the wires over to the board that's going to filter out your noise, you can have that EMI radiating onto other components within your circuit board, unless you have a complex housing for it to keep it shielded, or you shield the braiding. There's a lot of components to the system that need to be anticipated for this EMI radiation. And then again, you might get some re-radiation from the circuit board itself. With a filtered connector, what you get is you get the signal filtered out right at the connector level before it enters the LRU. So the dirty signal, quote unquote, never enters your LRU. So it removes the need for any type of circuitry or mounting or any other type of grounding that you require, because the connector will be grounded to the chassis itself, and the signal gets attenuated right there at the entry point. Now, Amphenol Canada's connectors, we have a wide variety of filter configurations, and we can pretty much filter any of our connector series, whether you have a requirement for a 24308 or an 83527, an ARINC 600, an ARINC 404. We do audio connectors as well, and if for our European market or rest of world market outside the US, we also filter circular connectors. Now, one advantage of our connectors is that we've got a ruggedized system that protects the capacitors. Now, as you all know, capacitors are pretty fragile because they're made out of ceramic, and under shock and vibe conditions, you can have some issues. We are ready to filter filter your connector and provide you a ruggedized solution. Not only that, we actually have our own machine capability in-house, machining capability in-house, both screw machine to provide you with contacts, or a machining for shelves and housings and inserts. We have a mold facility. So we have access to a full fabricating facility here in Amphenol Canada, located in Toronto, where we can provide you a custom solution. So a custom solution is not very difficult, especially when our engineers can walk across the hall to the manufacturing facility and provide you with the connector the way you want it. We also own our own ceramic facility, which is located in Belleville, Ontario, which is just outside of Toronto, 2 hours outside of Toronto. And there we can provide you with connectors, filters, capacitors. So here's our Amphenol connector. We have our solderless design. And the advantage of the solderless design is that your joints are more robust. You have increased reliability as well as increased life of the system. I'm going to turn on my pointers here. Arrow. Okay. So the one advantage is of our connector. Sorry, where's my arrow? I'm trying to get my arrow here. Arrow options, visible. Okay. No, it keeps turning. Sorry for that. Anyway, hopefully you can see the pointer on the screen here. Contacts are connected to the capacitor through a spring clip. And I'll have another picture to give you a better idea there. So what that does is it provides you with a joint. Because it's a spring joint, it can withstand shock and vibration and makes this more robust. Where a solder joint can potentially crack on you, our spring clip will maintain contact to the capacitor from the contact pin. The other thing that's important too is that the capacitor is isolated for shock and vibration because it is sandwiched between hard inserts using a rubber insert here. And what this does is it provides support and protection, a shock absorber if you will, for the capacitor in the fore-aft direction. So keeping in mind that these ceramic capacitors are very brittle and can crack quite easily, it's protected for you in the Amphenol Canada system. We also, in order to ground to the shell, you also have the ground spring which connects the capacitor to the shell, and that gives you the up, down, and crossways stress isolation through the insert here. Another sample here, or so you can see a better example showing you how the spring here is contacted to the pin. Now, one of the advantages of this system too is unlike a solder joint connection, our contacts are removable. So that's an important note for you engineers out there or people who are into reliability. If you have a problem with the contact, if the contact gets bent or damaged in any way, you have the ability to replace it. The other advantage of this system too, which is also important, is these connectors are factory repairable. You just send back the connector back to us and we can replace the capacitor. And let's say you've designed a system with a certain type of capacitance and you require a different type of capacitance. Maybe you need a few feed-through holes. What we can do here at the factory is that we can remove the capacitor, we can remove the inner components and reassemble it at a very cost-effective manner. And then this also shows how the capacitors are grounded to the shell through a spring. So under shock and vibration, this way and this way, it's all stress isolated. So with our facility that creates our own capacitors, we work hand in hand with them in trying to optimize the design of the capacitor. For those of you who don't know what a planar capacitor is, the original capacitors used in connectors were tubulars, and if you see this arrow here, I'm pointing at a tubular capacitor. Each contact was an individual capacitive element on its own, and you would be able to install and remove each capacitor. So that allowed you flexibility. The only problem is these capacitive elements or contacts were quite expensive. So in the planar design, we were able to reduce the cost and also provide you with a sturdier solution. In the monolithic hole capacitor, as you can see here, each hole acts as its own little capacitor connected to a common ground plane, which is around either at the top or it could be all the way around the capacitor. And what we can do for you is provide you with either feed-through holes, ground lines, or various capacitances within the planar capacitive element on its own. If I go back here, this gives you an idea how the capacitance works. You have a ground line, a connection line here to a electrode. Then from the ground plane here, you have another electrode. So the capacitance is made up of this overlap times the conductive capacitive material. So we have a variety of materials that we use and various dielectric strengths, and with that you can achieve various capacitances from very low to very high. Very high being up to 100 nanofarads, and for very low we usually look at 50 picofarads as usually one of the lowest that we go to, but most commonly used is 200 picofarads. Now, as far as capacitive circuitry, we have 5 basic levels or basic options: C circuit, a pi circuit, an LC circuit, a CL circuit, or a T circuit. So just to explain a bit more what those are. The C circuit is just a capacitor grounded to the shell. A pi circuit is comprised of 2 capacitors with an inductor in between them. And the reason why it's called pi is if this drawing here was extended, you would have a capacitive element up here. Oops, sorry about that. A capacitive element, and an inductive element here. So it would make the shape of the Greek letter pi. Then what you can do is you can also have a C circuit or a capacitor with an inductive element behind it or in front. So that's the CL or the LC, as well as a T with the circuitry, with the capacitor surrounded by 2 ferrites. Now the attenuation depends on the circuit, and here's a couple of samples of typical attenuation. As you can see, a pi filter will filter out more. A lot of people are concerned about 100 dB. So with 400 picofarads, you can filter out at 100 megahertz 25 dB. Whereas to get to 25 dB, you would be roughly at around 2,000 picofarads. So if you're up at 2,000 picofarads in a pi circuit, you're at 45 dB attenuation. So I guess you can look at one as a low-pass filter and the other one as a high-pass filter, and you choose the filter that you want, and we can provide you with the connector that you would like. Now here's an example specifying filters. This is one of our customers had a connector that they required a variety of filters. Not all of these are on the same capacitor, but they can be. This one here has 94 picofarads. This one here has 9,400 picofarads. This one's 940, 100, and then 200. And these are all in pi circuits. Now, usually what we do is we have a limit of 10% between the highest and the lowest. So filter A and filter F can be on one capacitor. Filter A and filter B can be on another. So this is actually for an airing style connector with 3 cavities, and they had the different capacitance values. So you specify the pi circuit. You can specify your working voltage. Now if there are transients involved, we will take that into account, and then that could affect and control what your capacitance is. Insulation resistance per capacitor, dielectric voltage, withstanding voltage, you specify, and then you can specify your attenuation, and we will work with you in achieving the proper values for the capacitive elements in order to achieve the minimum attenuation that you require. Choosing your filtered connector. So again, for the previous slide, you pick your operating voltage, you pick your operating currents, you pick your temperature range, and if the capacitors are to be operating within the capacitive limits within that temperature range or not. If we go back to this slide here, you can see that the capacitance, this is taken at room temperature, and that will come with normally a plus or minus 20% tolerance on it. If you need that, and that's only at room temperature, if you need something different to go across the minus 55 to plus 125 capacitance level and still hold the plus or minus 20%, then we're going to have to do some work on this to get that to specify the proper tolerance band, tolerance range to operate within those temperature ranges. Take a look at your transient voltage requirements as well. If you've got a 200 volt operating voltage, if you've got transients, then that bumps it up, and we'll have to bump up the DWV as well. So these are all things to take into consideration, as well as picking which circuit you require. Now, choosing the right capacitance for your filtered connector. Again, you have to look at the attenuation that you require for that connector. I remember working on one design, and they had a very high capacitance on this connector. What happened was that the customer realized that there were 2 pins that needed a signal to go through were getting filtered out. I guess it was a very low frequency filter, and it just, because the capacitance was so high, the connector filtered out that noise. And again, here's the advantage of the Amphenol Canada system. When that connector was returned to us, what we did was remove the springs from those 2 locations. We applied a conformal coat to the inside of the hole so that the pins were a feed through, and it worked great for the customer. So we were able to repair that quite cost effectively for the customer, rather than having a solder design where you basically have to probably throw away the whole system. So that was an advantage. Now, getting into electromagnetic pulse and EMP protection for the connector, we can apply Zener diodes or varistors into the connector itself. As you can see here, we have a picture of a filtered connector, so it does have the regular capacitive elements in here, as well as the diode and MOVs for EMI suppression. So what this can do is, in case of lightning strikes or any spikes in any type of voltages and current, you can protect your box right at the entry level, rather than having the surge come in, possibly burning out the wires before it even gets to the circuit board. You can have everything filtered out and suppressed right at the entry level to your system. So again, our engineers here, our electrical engineers, will work with your team in trying to determine the best application and solution for your system. Now, one thing, again, like I mentioned earlier, we have our own machine shop, we have our own mold facility, we have our own tool room. We are ready and able to help you solve unique design problems. Whether you have a compact connector with high density spacing for contacts, whether you have a more complex system. What you can see here is we're working with one customer in which they were concerned about EMI windows around the connector. And obviously, if you have any type of hole in an LRU, you have the potential for an EMI window. And you can solve that by applying EMI gaskets or EMI coil springs or a wide variety of solutions. But this one particular customer said, you know, and we were working with them, they said, okay, they have this problem. We said, here we go. This is our solution. Why don't we build the connector as part of your panel? So the customer required an EMI connector. They required the panel to begin with, and they required a connector. By having it all as one unit, they were able to, you know, knock off some EMI window around here, as well as some price or cost off their system by, you know, sourcing out the different springs or the gaskets and all that. It was just removed. So they paid the price of the panel and the connector as one unit. So that was a reduced cost for them. So we're ready to work with you and your engineering team to come up with the most optimal solution for your system. Now, here at Amphenol, we have our own testing facility. All the connectors are tested. Each filter is tested for DWV, IR, and capacitance, your insulation resistance and capacitance, and as well as we look at the attenuation for each of the connectors at the various different capacitance types. A sample size is taken. We have the ability to do measurements using insertion loss bells, which house the connector. And we also look at mechanical inspections, electrical tests. We look at leakage, and we also have the ability to do thermal shock and cycling and burn-in. For those of you who have space applications, we degas our connectors as well so that components will not leak out any gas into your system in space applications. So if there are any questions, just remember that Amphenol Canada's advantage is we have unsurpassed quality, we have low-cost solutions, we have custom solutions, and maximum innovation here at Amphenol Canada. If you have any questions, feel free to contact me. If there are anyone here who has a question listening in, please feel free to ask.
Thank you so much, Franco. I really appreciate you taking the time to walk through all this information with us. A lot of really helpful, useful information to anyone wanting to get a better understanding about filter connectors. So thank you. I'm going to go ahead and stop the recording.